My name is Masashi Misawa from Showa University, Northern Yokohama Hospital, Japan. I am honored to talk about our group's work entitled Development of a Computer-Aided Detection System for Colonoscopy and a Publicly Accessible Large Colonoscopy Video Database. Recently, artificial intelligence systems for colonoscopy are attracting attention. Especially computer-aided detection or CADE for colonoscopy using deep learning is eagerly investigated topic. Unfortunately, it is said that about a quarter of neoplastic polyps are missed in one colonoscopy. To reduce these dismissed polyps, many research groups and industries are investigating CADE for colonoscopy. However, there are two issues. First, there are still not many regulatory approved CAD systems available. Second, it may be difficult to objectively compare the performance of the different AI systems. We believe that the performance of AI systems should be assessed using a uniform test platform. So in this study, we aim to develop a CAD system for colonoscopy. And secondary aim was to construct a publicly accessible large colonoscopy video database that can be used for evaluate AI systems. We prospectively collected colonoscopy videos from 5 academic centers in Japan to develop video database. During study period, eligible colonoscopies were recorded by using high-definition recorder, and every single frame of all video was annotated according to the presence or absence of polyps in the frame. In addition, the locations of polyps were annotated by using bounding boxes. And then we developed CADE using deep learning-based object detection algorithm. This system was trained with about 56,000 images using transfer learning. I'd like to show the short clips of this system. Current RAS system was designed to output only an alert with sound and color, because we wanted to avoid disruption of endoscopy's concentration by showing a false positive bounding boxes. Let's move on to the result of this study. Regarding the open access database, 1,635 polyps were eligible as a candidate for the database, and we randomly selected 100 polyps according to the inclusion criteria. As a result, about 50,000 polyp images and 100,000 images without polyps were registered as open access database. These numbers far larger than those in existing database, and it will reflect a real-world environment. Therefore, this database should contribute to direct comparisons of existing CADE for colonoscopy. We named this database as SUN database. If you want to use this database, please contact us via email. Although our commercial use is strictly prohibited, it can be used for free. With regard to the performance of CAD system, the sensitivity and the specificity were 98% and 93% respectively. The detail of the performance was shown in Table 2 in the article. The performance of our CAD system surpassed those of previous studies. We think there are two factors. First, the number of training samples of our system was larger than the previous studies. Usually, the larger the number of training samples, the better the performance of the deep learning-based AI system. Second, we only used images derived from video, which may be more suitable as learning material for CADE for colonoscopy, because the still image decoded by endoscopist may be subject to considerable quality bias. Let me conclude. We developed an AI-assisted CADE for colonoscopy, and the system was validated using a large, novel, publicly accessible colonoscopy video database. The CADE identified colorectal polyps with 98% sensitivity and 93% specificity. Thank you for your kind attention.